Hi guys, this is section 8.2, homework problem number 10. You are given a set A which contains 4 elements and a relation which is defined here. So with this relation we can quickly draw a directed graph which is shown here. Let's take a look at that. For point 0, 0 is related to 0, so 0 we draw this graph, right? And then 0 is related to 1, so arrow pointing 0 to 1. 1 related to 1, so 1 we draw this little circle. 1 related to 2, so 1 arrow pointing to 2. 2 related to 2, so this is the arrow pointing 2 to 2, and 2 to 3, right? Arrow from 2 to 3. Now our task is to determine whether each of the following is true in this relation. So let's read through that. The first is irreflexive. That means it's not reflexive, right? So if you remember, the reflexive is x is related to x, and that's the reflexive. So let's take a look at a reflexive. We say a set relation on this set A is a reflexive if and only if for every x in A, x is not related to itself. Now, this is pretty easy to see in this particular relation. We do see 0 is related to 0 right there, right? And so therefore, for every x in A, x is not related to x. This is already not true. So this is not true. Therefore, we can conclude that. So because 0 is related to 0, therefore this R2 is not a reflexive. Well, to be reflexive, you cannot have that. And also you cannot have that. 1 is related to 1. You cannot have that. 2 is related to 2. Now we actually have 3 occurrences, like 3 elements that they are related to itself. So therefore, but we just need 1, right? 1 is enough to prove that it is not reflexive. Now let us take a look at the second one that we want to check. Asymmetric, right? So it's just the opposite of symmetric. Now what is that? That means for every x and y in A, so arbitrary x and y in A, if x is related to y, then y is not related to x. Now, this actually, if you use the special case that we just used, like these ones, right? These ones, you can see because, like for every x and y in A, so I'm gonna pick the elements 0 and 0 in this case, they're both in A, right? Now, because let's choose, let x be 0, y be 0, so they're both in A, right? And we can see that if 0 is related to 0, this is this 0, this is this 0. However, we already see that like 0 is related to 0. I should not use if, okay? But at the same time, 0 is also related to 0, but this time the first 0 is my y, the second 0 is the x, right? So in other words, this property is, I already found one special case here, so that the first zero is related to the second zero, but the second zero is not is also related to the first zero. So therefore, this property is not true. We already found a counterexample, and obviously, you can use 1 and 1, 2 and 2. They both show that this asymmetric property is not true. So therefore, R2 is not a symmetric, right? Symmetric, okay? Let's check the third one, intransitive. That means for every x, y, z in A, if x is related to y, y is related to z, with the in, that means the opposite. Then x is not related to z. Now actually we can find different examples. Just use the simple one. Let's begin with 0. So I strongly encourage you to find another counterexample. So for the third one, you can check this. 0 is related to 0. That means according to this guy, right? And also 0 is related to 1, the second one in this relation. And so here, think of this as your x, this is your y, right? And this is your y, this is your z, right? But this time the x, which is the 0, is actually related to the z, which is the 1. So therefore, this fails. I found an example that this condition to be intransitive, the requirement to be intransitive, that fails, right? So therefore, we can conclude, therefore, R2 is not intransitive. Okay, so this is the little explanation for this particular problem.